I'm not sure the chat is working right now. I'm gonna mess around with some things, see if I can get that going while that pops up. Alright, I'm not so sure why the chat is not working. If you have a question or a comment, I don't know if you know how to use Hangouts or not, but you can shoot it through Hangouts. I'm not sure if that'll work for you or not either. I'm gonna have to set all that up right now. So that's alright. I guess I'll do it without chat. We'll go over the test tomorrow, I guess. I was gonna go over that today. Today I guess it's just gonna be a video. Sorry, I don't know why the chat is not working. I'll have to look into that. I have a feeling I know why it isn't, and I can't change that right now. So I will test around with it later. That being said, we can go ahead and start talking about today's lesson. If you have questions or don't understand things, you can email me, but it really should not be too difficult because we've kind of been doing this all year. Please make sure you are following along with the notes, see if you have any questions on that, but we are going to be talking about square roots today. And we've really been talking about square roots all year. Any chance that I saw to throw in a square root, we kind of did. Just so you are not confused, in the PowerPoint when it says things like the square root of 16, I wrote it like that because Google does not let me put this line above that bar so you know what's under there. So whatever is in parentheses after this symbol is what's supposed to be underneath the square root. That way we can determine whether things are supposed to be under that or not. So first off, what is a square root? Square root is, okay, again, if you're following along with the notes, it's in the notes, but it is any number a, so a is a square root if a squared equals b. So if you're given b as 16, so if b equals 16, a squared has to equal 16. A would be your square root. So it kind of undoes squaring. So the square root of a squared is going to equal a. These and this will cancel out and give you a. So for example, you have the square root of 16. You want to ask yourself, a times a has to equal 16. Well, what are the possibilities for a? Well, you could have 4 times 4 equals 16, and you can have negative 4 times negative 4 equals 16. So there are two answers to these. They equal plus or minus 4. This little notation tells me, hey, I want the positive and negative of it. So it's just a plus sign, and underneath you have a minus sign. So I want the positive and negative of it. It is normally implied that the square root of 16 will equal 4, and the negative square root of 16 would equal negative 4. So the signs in front of your radical kind of imply which one you want. However, if you don't write a sign, it is kind of a bit confusing. So this one could have both answers. It is better that this has both answers. If it says the negative square root of 16, it's just asking for the negative version of it. Technically, this is, a lot of things say this implies just the positive square root, but I would like you to keep in mind that it has both the positive and negative when you write it like this. So this equals both of them. This is just going to equal the negative version. If you have something like, hey, I want, and there's a positive sign there, you never see it, but then it'll only want the positive version. But if it doesn't have a sign in front of it, you want both. If it has the sign in front, you want the negative. Just for that. Terminology you need to know. This symbol here is called a radical. Let me make sure I spelled that right. Yeah. That is called a radical. So whenever I say there are things under the radical, I mean whatever is underneath this symbol here. The number underneath that. So for example, the square root of 16. Right? This sign is the radical. The 16 here, that is called a radicand. So this number here is a radicand, and then it's under the radical, and it's asking you to take the square root of 16. Occasionally you have other roots, like if you want the cube root of something, you would put a 3 up in that little, above that little check mark spot, or you can have the 4th root of something, or however many roots you want. Oh, excuse me. But yep, just terminology. The other thing that you need to know today, and if you don't, I would be surprised, but you need to know what a perfect square is. So if you don't know your perfect squares, make flashcards and memorize them, but you probably have these memorized since like first grade, or not first grade, but like 3rd grade when you started learning your times tables. A perfect square are the squares of integers. So if we have an integer, and again this is in the PowerPoint, you can follow along with there. If we have an integer and we square it, we get a perfect square. So for example, our integer being 1, then 1 squared would be a perfect square, which is 1. So 1 is a perfect square. If our integer was 2, 2 squared would be 4, so our perfect square is 4. Right? I guess I set it up as a table in the show. Right? 3 squared would be 9. 4 squared would be 16. 5 squared is 25. 6 is 36. 7 is 49. 8 is 64. 9 is 81. 10 is 100. And you should have 11 and 12 memorized just because you know your times tables. It's 121 and that's 144. This you need to memorize. You need to know that. You need to know your perfect squares. You should know them just by thinking of your times tables. Hey, what times itself is going to give me a number? Well, 6 times 6 is 36, so 36 is a perfect square. If you know those, doing square roots is not too difficult. It's just keeping some reasoning straight. Next thing about square roots is rational versus irrational. And we've gone over this as well, but you have rational numbers, remember those are fractions, or can be written as a fraction. It doesn't necessarily have to look like it, but it can be a fraction. And then you have irrational numbers, which are not fractions. And this is cannot be a fraction. So those are the difference between those two. Remember, rational numbers will either terminate, which means stop, or they will repeat in a pattern. Like that. They'll repeat. You can have a repetent form. Irrational numbers do not stop and do not repeat. So again, you probably know a lot of examples of rational numbers. Irrational numbers, you probably, well, you've worked probably more with them this year than any other year. But irrational numbers are your numbers like pi, like e, phi, if you know your golden ratio. Those weird pattern numbers like 0.12, 112, 1112, 11112. See, they don't repeat, but there's a pattern to it. And then you also have square roots that aren't perfect squares. So for our purpose, right, the square root of 16, because that's what I'm using this whole time, is equal to plus or minus 4. This here is a rational. I can write 4 as a fraction, and therefore it is a rational. Note that it is also 16 is a perfect square. So 16 is also a perfect square. Right? Anytime you have this number being a perfect square, it's going to be rational. And that's one of the reasons why you need to have those perfect squares kind of memorized, so you can look at it and be like, well, the square root of 81, that is rational, because I know the square root of 81 is 9. Square root of 37, that is not a perfect square, and therefore it's going to be irrational. So the other example would be the square root of 2, which is a pretty common one. It's going to be plus or minus 1.42 something, and it's going to go on not repeating and not stopping ever, will be irrational. So this is irrational because this is not a perfect square. So it's pretty simple to tell the difference. You just have to know your perfect squares and what aren't your perfect squares. And as things get higher and higher, feel free to use the calculator. It's not going to be too difficult. Let's see, last thing I want to go over in the notes are fractions, because you can take square roots of fractions. So let's say we're going to take the square root of a over b. So here we have the square root of a over b. It's the square root of a fraction. This is going to be equal to the square root of the numerator divided by the square root of the denominator. So these are the same thing. This here is a nicer way to write it, but it means the same thing as this. So if we want to put numbers to it, for example, we take the square root of 9/25 because they're both perfect squares, right? So that's going to equal the square root of 9 over the square root of 25, which equals 3 over 5 and negative 3 over 5. And again, you could have used the plus or minus, I guess, instead of writing them both twice. This is going to be tough to get on your computer. I think it might be under symbols, but that's kind of a tough symbol to find. So that's the information you need to know for your assignment today. Tomorrow, I hope the chat will be working. I did make a few adjustments on the computer, and I think it threw off the chat. But your assignments for today, and I can look at a couple of them with you just so you get started on the right track. I'll do some from each group here. But you're looking at page 526, 1 through 37. And with that, I can start with like number, let's see, do number 1. Oh, I want you to do the odds. So 526, that's not right. Is it? Yeah, maybe it is. I'm on the wrong page. 526. Yeah, that's right. So number 1 is going to ask you what the square root of 169 is. You should, you might know that. If you don't, you feel free to use the calculator. It will make your life easier in the long run anyways. When you get to a quadratic equation, you're going to want to use your calculator anyways. But you should know that this is plus or minus 13. So this is saying 13 times 13 equals 169. And again, square roots we've kind of been doing all year. It really shouldn't take you too long to finish this. Some of them you might get to and you're not sure, like number 2 says square root of 400. You don't have to do number 2, but just for the sake of seeing it, square root of 400, you can separate that out, and we will get into this later on, but this does equal the square root of 4 times the square root of 100. You can factor that and split that up. I know 2 factors of 400, 4 times 100. And in this case, I know the square root of 4, which is 2. And I also know the square root of 100, which is 10. And therefore, you're going to get 20. And again, it's plus or minus because it's a square root. So things like that you could probably figure out. You can break up. I'm not sure what other ones do that I assigned to you today. I gave you some with decimals, so like number 9, square root of 0.36. Just watch where your decimal point is. Notice how the 36 is a perfect square. So this is like taking, I don't know how to explain that. Yeah. Well, one way to look at it is to multiply this, your radicand, by 100 and then divide it by 100 in the end, but really just watch your decimal point. And that's going to be that, plus or minus. But you could look at it as, hey, I'm going to take that radicand, I'm going to multiply it by 100, and then I'm going to take the square root of it, so that's going to equal 36. Then I'm going to take the square root of it, that's going to equal 6. And then because I multiplied by 100, I have to undo that. I'm going to divide by 100. Actually, that'll only give you point. Oh, I took the square root. I got divided by the square root of 100. That's why. And that'll give you the 6 divided by 0.1, which will give you the 0.6. Or you can just think of the decimal, just don't lose your decimal point on where you're doing things. So that should get you through the first section there. What's 13 and 15 like? 13 and 15, you just have to tell me if it's rational or irrational. And again, if it's a perfect square, it'll be rational. If it's not a perfect square, it'll be irrational. This shouldn't be too difficult for you. Let's see, 17 is estimating. We can go over an estimation one. So it wants you to estimate the square root of 35. Here, you should use your perfect squares. That's why we know them. We know 35 is not a perfect square. However, we do know the square root of 36 equals 6, and I do know the square root of 25 equals 5. So this number here, I guess we can do plus or minus for both of them, has to be equal to something between 6 and 5. And being that it's 35 is closer to 36, you're probably thinking it's closer to 6 than it is 5, so we can say it's like 5.9, 5.85 or something close like that. It's between 5 and 6, so you should know that. I can do another one of those with you. Again, 18 you don't have to do, but it is saying the square root of 27. You know which two perfect squares it's between. You know the square root of 16. Actually, I'm sorry, you know the square root of 25. I guess this is the same kind of thing. And the square root of 36. This is plus or minus 6. This is plus or minus 5. This is closer to the 25, so this is going to be like plus or minus 5.2, something like that. And again, it's going to be irrational. It's going to go on forever and not repeat. You don't have to be exact. It's just asking you to estimate it. Let's see. Next set is... Oh, I don't want to do that. 21 through 25 is just using your calculator to do them. So go ahead and use the calculator to solve them. And 27, find the square root of each number, is just kind of finding square roots again. Again, try to do them in your head. If you're completely lost in your head, just type it in the calculator and you'll get it. With that, I'll give you the next 15 minutes to work on it. Again, I apologize about the chat. The other thing I want you to do is look at your test. They were graded and handed back to you. I would like to go over that when the chat happens, so I'd like to go over it tomorrow, which is going to put our lesson for tomorrow on hold because I kind of wanted to do a little bit of it today. If you didn't take the test yet, please do so. I'm still waiting on a handful of you to do that. Look at it, fix anything that I crossed off. Biggest mistakes on the test that I really want you to look over is combining like terms. Make sure you've combined every like term that you can. After you do that, the naming. A lot of you miss just, hey, what is the name of this polynomial? So look at the naming. And a lot of you missed that because of the combining like terms. You didn't combine like terms first and then name it. The other big mistake I saw was, I don't remember, something else I wanted to mention about it. Oh, the standard form thing. A lot of you didn't really put things in standard form. I didn't take off for it because I only asked for it for the first two. But you should be putting everything in standard form if you can. So for example, like, I'll do 6 with you. This is on the test. Number 6 was 5m times 3m plus m squared. Right, you just distribute it. It's asking you to FOIL this. So you really just distribute it. So 5n times that and 5n times that is going to equal 5m squared plus, or I'm sorry, 15m squared plus 5m to the third. It really should be written in standard form. So this here is the correct answer, even though it's the same thing. If you flip those around, I didn't take off points, but just keep in mind, put things in standard form. So highest degree monomial first, followed by the others. With that, if you have questions, send me an email. Again, I apologize about the chat, but try to get the square root thing done by the end of the week. When it comes to assignments, just because we've been doing weird things online, try to get things in by the end of the week. Get things by the by Friday for things, and so on. I will talk to you tomorrow then. So again, email if you